Alright, so in this video, I'm going to be finding the antiderivative of the natural log of x over x dx. So this problem might seem intimidating at first, but one simple substitution, u substitution, is going to make this problem a lot easier. So let's set u equal to the natural log of x. Doing this, du is going to be equal to 1 over x dx. This really simplifies the problem because notice that I can make this integral. So the natural log remains, and then let me do that in white. The natural log remains, and then we have u here, and then over x, this can be rewritten as times 1 over x dx, which we know is just du, so we can replace that with du. Make this red, u, and then du, and that's it. So this sign was a little too big. We can write it smaller. So this is what we can write it as. Now the next thing that we can do is we can use integration by parts and set. So let me use integration by parts, and I'm going to set this portion equal to n. So n equals the natural log of u. I'm not using u because u and v because u is already used up here, so I'm not going to be using u. You can use a different variable, but when u is used up, I like to use n and m. It's just something I like to use. So the n is the natural log of u, so dn is equal to 1 over u du. Okay, and then the next part is du. So that's going to be v. dv is equal to du. So v is equal to just u. This is quite simple. And I know I used v, so let me change that. Let me make that m, because I don't want to confuse myself here. I'm just going to make this m and m. Okay, now we can write it out. The integration by parts formula, integration by parts, and typically this integration by parts is used when you have like two parts being multiplied together, and you need to integrate it. So integration by parts. So this is integral of, in this case, I'm going to be using n dm is equal to nm times minus integral m dn. So again, why do we use this integration by parts? We're essentially trying to simplify the integral so we can solve it. By breaking it up into these two portions, we can quite easily solve this problem. And integration by parts, it's important that you choose the right u, in this case n, because that really makes a huge difference on whether it's going to simplify it or make it more complicated or keep it the same level of complexity. We always want to make it less complicated. And integration by parts is used, it's kind of like a reverse product rule. And so whenever you have like two things being multiplied together or like divided in a certain way, you can use the integration by parts formula and integration by parts to integrate. Okay, so now that we have that, we can rewrite this. So this is equal to the integral of the natural log of u du is going to be equal to n times m. N is the natural log of u times u minus integral m, which is u, and then divided by u du. Basically what I had here was u times 1 over u du, which is just 1 du. And so this is actually just equal to the natural log of u times u minus u plus c. And that's it. But remember, we had the x world. The answer was in the x variable. So we need to make sure that we convert this back to the x. And that's quite simple because we had u equals the natural log of x. So we can change that. So this is equal to the natural log of x times the natural log of x minus the natural log of x plus c. So lots of natural logs here. We can simplify this by taking out a natural log of x, multiply by natural log of the natural log of x, natural log of x minus 1. So this is, yeah, this is going plus c. This is kind of a simplification, didn't really simplify it much, but this is a way we can also rewrite the antiderivative of this function. Okay, so that involved u substitution and integration by parts, and the main purpose of this problem was to go over integration by parts. So I hope you found this video helpful.